Okay, welcome to lesson 12 in polynomials. So this is IM Algebra 2, topic 2. The notice and wonder. You can write down whatever you noticed, you wonder. I am going to bring up a couple of things, and then I'm actually going to walk you through how to solve this bottom one so we can get more practice, because division is a little more involved in that it entails multiple different operations all at once. So something to remember is that when we're multiplying, we put one of our factors on the side and then the other factor up top. It doesn't matter which way you do this when you're multiplying, it should still give you the same answer. So that's where we're getting those numbers from. And then when we're actually in this process, x times x gives us x squared, which we see right here. This 2x is going to come from when we combine like terms. So negative 3x plus 5x. So you have 5x minus 3x, or if you wrote it negative 3x plus 5x, that is what gives you that 2x. And I'm going to highlight these the same color just so you can see. And then lastly, we get that positive 5 times negative 3 is our negative 15, and that cannot be combined with anything. We can repeat a similar process in the next one. We have one factor on this side. I did not highlight that very well, so there's one factor. Then we have our other factor. And the nice thing about using this area model, or the box method if you want to call it that, is that you can expand it or shrink it to match whatever you want. So we had a 2 by 3 or 3 by 2. I never really remember how to properly say that. My x cubed comes from x squared times x. My 2x squared comes from combining my negative x squared with my 3x squared. So similarly to what we did up here, where we have 3x squared minus x squared, you can put that 1 right there. That's the same as saying negative 1x squared plus 3x squared. They are both going to give you that same answer of a positive 2x squared. And then we can also combine our negative 3x and our negative 4x to give us negative 7x. Because both of them are negative, the shortcut is to add 3 plus 4 and then make your answer negative, because they're both negative. That only works if they're both negative. You're going to hear my dogs whining because they think they need to cuddle with me all the time. Okay, here's the 4 coming from multiplying a negative 1 times a negative 4, and that's how that matches up. Now for this last one, the way it's set up is division. And the reason it's division is because we know what this side is, and we're dividing by this. So you might see it as x cubed minus x squared minus 4x plus 4 divided by the factor of x minus 2. So that's how you're going to see it set up. And then I'm going to word it several different ways. Figure out which wording you like best, and we'll go from there. Technically, you can say x cubed divided by x. You can also think of you have 1x, but you want 3. How many are you missing? Or what times x would give you x cubed? Well, I'm going to go ahead and put x squared, because 1x plus 2 more gives me 3. And then you're going to start seeing what I mean by you use every operation when you are dividing. X squared times negative 2 is negative 2x squared. Okay. Right now I'm at negative 2x squared, but I want to be at this negative 1. So negative 2x squared plus or minus something is going to give me that negative 1x squared that I want. These two should be able to be combined because they're going to be like terms. So I need to think about, how am I going to get from negative 2 to negative 1? Well, if I have a number line, and this is 0, negative 1, negative 2, to get from here to here, I'm just adding 1. So I'm going to put 1x squared, and it is a positive. Normally I don't write this one here, but I'm going to so that we can really get this to line up properly and make sure that we are keeping track of all of our x's. So I'm going to highlight this x cubed before I forget right here. And then I'm going to have my x squareds right here and right here. Before I forget, I'm also going to highlight these because they were combining like terms to give me that -1. Okay. Now I can kind of repeat the process. What times x would give me x squared? Well, that's just a singular x. I had one x, I wanted 2, I got one more. Okay. -2 times x is -2x. I'm at -2x, but I want to be at -4x. Y'all are gonna hear and see all of the animals today. So this is -1, -2, -3, -4. How I get from -2 to -4 is I am subtracting 2. So I'm going to subtract 2x, and I'm going to put that right here. Again, that's because when I combine these together, I get what I originally had, which is the purpose of this whole event. I do really like color coding. You can also like shape code, so put them in triangles, squares, rhombuses, whatever you want to do. Close my highlighter, and I don't know why I did that. Okay, now I need to repeat the process one more time. What times x would give me -2x? Well, a -2 would do that. Because if I multiply -2 by x, I get -2x. -2 times -2 is a +4. I really like using my constant as a check to make sure I did it correctly, because if this constant that you get when you're dividing does not multiply what, or does not end up with what you multiply, wow, I am struggling. If this constant does not end up matching with this constant right here, it is one of two things. Either what you divided by is not a factor, or you messed up somewhere on the inside. So one more time. If these two constants do not match up, it is either because this over here that you were dividing by is not a factor, or you made a mistake on the inside, which does happen, and that's okay. But again, use this to double check your work. Okay, in 12.2, we are given a long polynomial. F of 1 equals 0, so she suspects that x minus 1 could be a factor. Okay, we're going to repeat the process that we just tried in 12.1. Even though 12.1 was a notice and wonder, we wanted to get that extra practice with dividing. I want to remind you that factors and zeros, and I'm trying to figure out where I want to write this. Factors and zeros have opposite signs. What I also want to tell you is that when you have a factor, if it is a factor, there is no remainder. What that means is x minus 1 is a factor. So x equals +1. That means if you plug in f of 1 and you replace all of the x's with 1 and you solve it, you get 0. There is nothing left over. That's function notation to say all of this. Okay, so we can start this process. What times x gives us x cubed? Well, that do be x squared. X squared times -1 is -1x squared. Okay. I'm at -1x squared, but I want to be at 5x squared. So I'm going to take a second to highlight here before I forget. I have my x cubed right there. And I guess if you really want to, you can highlight it here or here, doesn't matter. You're going to see it in 3 different spots. I'm at -1x squared, but I want to be at 5x squared. if you struggle with negatives, something to think about, if you're at negative 1, 0, 1, 2, 3, 4, 5, you can make this number line. You can break it into two pieces. How many from negative 1 to 0? Well, that's adding 1. From 0 to 5 is going to be 5 more. So that's a total of 6 that you added. So I'm going to put this 6x squared right here. Again, that's because negative 1x squared plus 6x squared gives you that 5. So negative 1x squared gives you the 5 you want. If you switch the order, negative 1 plus 6 is the same as 6 minus 1, so that doesn't do anything. And I repeat the process. What times x gives me 6x squared? Well, I'm missing an x, and then I need my 6 in front. 6x times negative 1 is negative 6x. I'm at negative 6x, but I want to be at a positive 2x. So how am I going to get from negative 6 to a positive 2? Negative 6 to a positive 2. Again, if these number lines help you, from negative 6 to 0 is 6 more. From 0 to 2 is 2 more. So that's a total of 8 that you are adding. So this is going to be 8x. Again, I am sorry that you can't necessarily read that, but this is because negative 6x plus 8x is 2x. It is the angle of my, does that help a little bit? Not really. Okay. Make sure you write it down before I highlight it, apparently. I don't want to write in pen because I am known to make mistakes, and that's okay. You're going to make mistakes too. I promise you can see it when you are doing it yourself. Okay, last thing. What's x multiplied by to get us 8x? Well, that's 8. 8 times negative 1 is negative 8, which is exactly what we wanted, and that's how we can double check that we did this part correctly. So when we write f of x as a product of x minus 1 and another factor, it doesn't specify the degree of this factor, so we can say x minus 1, and then our other factor is what we wrote across the top. Okay. To break this into linear factors, linear means degree 1 or multiplicity 1, and that means we're going to have 3 because it is an x cubed, so we're going to have 3 factors. You can divide this again, but you might have to guess and check. The other way to do it is to do what's called factoring. Factoring is where you find two numbers that are going to add to your middle number that also multiply to your last number. So if you set up a table for things that multiply to 8, well, I could do 1 and 8. I could do negative 1 and negative 8 because a negative times a negative is a positive. I could do 2 times 4 or negative 2 times negative 4. So I have 4 choices here. I needed to add to a positive 6. So of these 4, 1 plus 8 is 9. Negative 1 plus negative 8 is negative 9. 2 plus 4 is 6. So I have my x minus 1, x plus 2, x plus 4. So when I graph, I need to think about standard form versus factored form. From standard form, I'm going to rewrite standard form without the highlighting so we can hopefully see it a little better. Okay. From here, we see our constant is negative 8. We see a degree 3 and a leading coefficient of 1. From our factored form, we see that our zeros are 1, negative 2, and negative 4. It's a degree 3 with a positive leading coefficient, so we know we're coming down in that third quadrant and going up in the first quadrant. We have our zeros at 1, so remember that is going to be between two lines, negative 2 and negative 4. They all have a multiplicity of 1. So I'm coming through, coming back down. Wherever you want to cross is okay, because remember, your graph might look a little different. I'm not plugging in numbers, so it's not an exact graph, but this will be 0, -8. And -4, 0. And that's your graph. If you want a quick review of end behavior, as x approaches -infinity, meaning as x goes to the left, y, or if you want to say f of x, approaches -infinity because it's going down. As x approaches positive infinity, or as x gets more and more positive going to the right, your y, or your f of x, also approaches positive infinity because it's going up. Okay, 12.3 is a lot more dividing. I'm going to do a of x with you. I'm going to talk you through a couple of different things to take into consideration for the others, and then I'll pop up the answers. There is more than one right way to do this, so you're going to see a couple of different ways. You can do whatever works for you. Yeah, we're going to start with that. Okay, so we're dividing by x minus 7. These numbers up here are what we're trying to equal inside. I will tell you they put a couple of extra boxes, so you can go ahead and cross out these last two. You don't need those. Okay. We always put our first term in the top left box, x cubed. Well, it tells us that x times x squared is x cubed, so we are good to go there. X squared times -7 is -7x squared. But when we look at this, and I'm going to be careful because I know you can't necessarily see the purple highlight, so I'm going to use it on the x cubed that already exists. This -7x squared is what we have. It also happens to be what we want. So they put 0 right here because we don't need to add or subtract anything to get from -7 to -7. If you want to do what's called placeholding and you pop that x squared there just to keep track of it, you can do that, and that's actually something I need to do, so you might want to do it as well. Well, what are you going to multiply x by to get 0? 0. And again, you don't have to, but I'm going to pop that x there just to kind of keep track of what goes in what blank and how it separates. Okay. 0 times -7 is going to be 0. And again, I'm going to include this x. So this was an x squared, this is an x. Well, I'm at 0, I want to be at -16. How am I going to get from 0 to -16? I'm going to subtract 16. So these two are getting combined together. 0 minus 16 gives me that -16 that I want. Well, would I multiply x by to get to -16x? Just -16. -16 times -7 is in fact 112, which is what I wanted, so I know that I'm good to go. I did this right. I broke it up correctly. Speaking of broken, I think my highlighter might be breaking on me. Okay, but we're not done. Okay, right now, try and do it without blocking my view. We have x minus 7 and x squared minus 16. Okay. This x squared is broken up like this. If you factor, which we just talked about in 12.2, you want two numbers that add to 0 that also multiply to -16. Okay. 16 is a perfect square, and when you see x squared minus a perfect square, it's called the difference of squares. The square root of 16 is 4. So this breaks up to x plus 4, x minus 4. Because if you multiply these two out, you get this. So if you were to do the box, your middle term, those x's would cancel, just leaving you with that. Okay, I'm just gonna bring up a couple of key points in the other 4 before I pause to fill in the rest of my work and give you the opportunity to do this on your own and practice this on your own. For B, it is a little more difficult because it is 3/2, which is a fraction. Some of them will cancel and be nice like this. If you want to convert this to 1.5, you can definitely try that. Remember, you can put stuff into the calculator, but you cannot include the x. So if you do -3/2 times 2, that would give you -3, and then don't forget to include your x's there. For c of x, I don't really have anything to say to you, except once you have divided, you're either going to divide again or you can factor. My preference is factoring. That is how I'm going to teach it in this video. But if you want to guess and check and try to divide again by what you think is a factor, that is fine. D gives you the hint. I would use your zeros as a placeholder, especially as you are going across. There's a couple different ways. It gives you more than one factor. So you can divide by one factor to begin with, does not matter which. Then once you get across the top, you can divide by your other factor. When I originally did this, I actually multiplied these two together and divided along my side by what I got to break this down faster. That's something that comes with a little bit more skill. You can definitely do it step by step. I will do it step by step this time around as I'm teaching and showing. And then you can keep dividing until you got it broken down. And the same for this last one, f of x. It gives you 3 factors, so you can divide, 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 and then maybe factor that last one as needed. You might have a couple of extra boxes in some of these, you might not. One more thing, I'm going to quickly remind you of that factor notation. This would be f of 7 equals 0, f of -4 equals 0, and then f of 4 equals 0. These are the zeros you would find from your graph. This is how you see it in function notation. If you saw f of 7 equals 0, then you know you would write x minus 7. If you saw f of -4 equals 0, you know x plus 4 is a factor. And then if you saw f of +4, you would know that x minus 4 does work to divide your standard polynomial. Okay, so I'm going to take some time to work through this. You might see my daughter's lovely scribbles in some of this work if I open up that notebook. But I'm going to divide. I want you to divide, 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 and then we will talk about those answers in a minute. Okay, I am back. I did all the work. I did my best to keep it on the paper so I don't have to flip back and forth for you. And then instead of highlighting, because sometimes it's harder to see, I was using shapes. It did turn out nicely. You got whole numbers, even though you were multiplying by a fraction. When you divide by this x minus 3/2 here, and you end up with 2x squared plus 2x minus 24. Oh no, I messed up. Okay, so let me show you what I did. I started thinking about dividing beforehand. So this should be that 24 from up here. And then here, what I did for each of these is I divided each number by 2. So 2x squared divided by 2 gives me x squared. 2x divided by 2 gave me x. -24 divided by 2 gave me -12. Obviously, then that is going to affect this. So I'm not using that -6. I want to use the ones that give me -12. So 1 times -12, 2 times -6, 3 times -4. And then I'm going to invert all of the negatives or flip them. Okay, so I have 6 options, and I want to add to 1 and multiply to -12. Well, the one that adds to a +1 is going to be here. So I'm going to change this sign to a negative, and then here. Okay, so I have +4 minus 3, which means I'm just going to cheat a little bit and make that a +3 and change this to my -4. Yep, okay, so fix that. Haha, this is why we double check our answers. Again, this is called factoring. We did all that. Okay, for number 3, oh good, you can't see it. Once you've divided by x plus 3, you're left with x squared minus 6x plus 5. You want two numbers that add to -6 but also multiply to +5 if you're factoring. and you should get -5 and -1. So then this is how you write that in function notation. If you were to divide again, you would have to end up guessing or using your best educated guess to divide by one of those factors. For number 4, there's a couple of steps, and I made a couple of boxes for you. And I used shapes, and I had to start using triangles. I repeat the process. Don't forget about these zeros. That's why I like the placeholders, because otherwise I would forget. Speaking of forgetting, real quick up here. +3, you wanted a -3, so you had to subtract 6. That is a very common mistake. It looks like I didn't do my negative, but I did. Be very, very careful. 3x squared minus 6x squared gives you that -3x squared that you want. Okay. Just before I forget that. Okay, back to number 4. This is my ADHD kicking in. You're welcome. When I divided by x minus 2, I just did the first one. If you want to divide by x plus 2 first, that's fine. It doesn't matter the order you divide in. It just means that these steps are going to be a little different, but your final answer will be the same. So one more time. It does not matter which one you divide by first. It might change what this looks like a little, but your final answer will be the same. Okay, so I divided by x minus 2, and I got x cubed, 2x squared, -9x, -18. I then took my top one and I divided my top one by my other factor that I knew. So then I had my 2x squared, and 0x squared gave me 2x squared. 0x minus 9x gave me -9x. And I still had my -18 that matched. X squared minus 9 is another example of that difference of squares we talked about earlier, because 9 is the perfect square with 3. So I have my -3, or x minus 3, x plus 3, +3, -3, and that one broke up pretty nicely. The last one was a nice, beautiful, long one, okay? I did x minus 5. I just went straight in order. Again, you can divide by whichever one you want first, doesn't matter. I divided by x minus 5. I got this. Then I used my top factor and divided by my x minus 2. I don't write these extra boxes on the side. I just write it on the outside. You can write it however you want. Doesn't really matter. Got 4x squared, 13x, and 3. Normally, we've been factoring when we get to this x squared part, but it did give us another factor, so I was able to use that factor to divide and find my last factor I was missing. Because I'm also not a fan of factoring when there's a number in front of x, that does kind of change your answers a little bit. I would look up a video on factoring when your a value is more than 1. Okay, so that's how it breaks up. That does give you -1/4, because when you solve 4x plus 1 equal to 0, you're going to get a fraction. If you want to convert that to a decimal, you can. That would be -0.25, like a quarter. Okay. So that is multiplication. We're going to go do some practice problems, and hopefully we are going to solidify our division knowledge. Okay, it tells us a known factor. This is the first time recently that we haven't seen the box actually made, so I'm going to help you learn how to make the box. There's a couple different ways you can do it. You can see that there are 4 terms. You're dividing, so you're getting smaller, so you're going to go down to 3, or you can look at the degree term. So I'm going to start by making a box that has 2, and then I'm going to say 3. It's hard because I'm writing over what I'm recording with, so ignore my awful lines here. I'm going to put my factor on the side, so I have x minus 4. This first term goes in my top left box, so I have x cubed. Well, what times x gives me x cubed? X squared. X squared times -4 gives me -4x squared. I'm at -4, but I want -3. So whatever I'm going to add to -4 to get me to -3 goes in this box, which is going to be a +1. x times x would give me x squared. X times negative 4 gives me negative 4x. I'm at negative 4, but I want to be at negative 10. So I'm going to subtract 6. Again, that's because negative 4 minus 6 is negative 10. I'm going to put my negative 6 up here because negative 6 times x gives me negative 6x. Negative 6 times negative 4 is a positive 24, which does line up. So right now I am left with x minus 4, x squared plus x minus 6. Now this is actually the problem that I miswrote earlier on the other page. So I have my negative 6 that I want to multiply to. Gotta make sure I'm gonna get all 4 of my options here. I want a number that's going to add to 1 that are also going to multiply to negative 6. So of these 4 options, the only ones that multiply to negative 6 and add to a positive 1 is this negative 2 and positive 3. So I have x minus 4, x minus 2, x plus 3. So in terms of graphing, and it does say rough graph, so it does not have to be perfect, one of our zeros is positive 4. Another 0 is positive 2, and another 0 is negative 3. My constant is 24. I'm going to start writing this so I don't forget. 4 to negative 3. My constant is my y-intercept, which is 24. My degree is 3, and my leading coefficient is positive. All of these were a multiplicity of 1. So something along this line, with this being your 24, and this being your 4 to negative 3. Ta-da! The next one, Tyler knows the linear factors, and he knows that p of 1 equals 0, so he suspects x minus 1 is a factor. Again, this p of 1 equals 0 means that if you replace all of the x's with 1, you would get an output of 0 because there is no remainder if it is a factor. He wants to check if he's right. What did he mess up on? He got the negative 15. Negative 15 minus 8 is a negative 23, but he wants a positive 23. Okay. Negative 8 plus 1 is not negative 9. So if you look, what he needs to have is this negative 1 right here. Just because he missed the sign means that all of these answers are going to change and need to change. So if you want to do the box again, and you set it up similarly, you have x minus 1. X cubed goes in the top left. That part was right. X squared goes across the top, which is also right. But then you have negative 1x squared. You want negative 9, so you're going to subtract 8 from it. That does pop up this 8x. This is a positive 8, not the negative that they started with. This is going to be a positive 15x. And this will be the negative 15 that they still wanted. So they look similar, but they're not the same. X minus 1, x squared minus 8x plus 15. I'm going to go ahead and factor this even though it doesn't ask me to, just so we can get some more practice. If 15 is what I'm trying to multiply to, I can do 1 and 15. I can't do 2, I can do 3 and 5. I can make my answers all negative. Something you haven't seen yet that I want to bring out, if this number is positive and this one is negative, you can ignore the positive side and just look at the negatives, because there's no way to add two positives and get that negative that you need. So we have x minus 1, x minus 3, x minus 5. So we already knew that p of 1 equals 0, but we also have p of 3 equals 0 and p of 5 equals 0. Okay, last one is number 3 that we're going to go through. It is dividing. Doesn't matter which one you divide by first. You want to get the answer. They all have x minus 2x plus 1, so you cannot use that for elimination. I'm going to go write it out in my daughter's sketchbook because that's what I have available right now. I want you to take some time to divide it and see what you get for your final answer. Okay, while I was doing this, I got it narrowed down and I had to contemplate what I wanted to show you all. So when you divide by this x minus 2, you are left with 2x cubed minus 5x squared minus 22x minus 15. If you use this to divide by that x plus 1, you're left with 2x squared minus 7x minus 15. Because it is a multiple choice question, if you want to multiply the 2 in front to see if you get that 2x squared minus 7x minus 15, you can. But I think it's a really good opportunity to show you how to factor when your a value, what's in front of your x squared, is more than 1. Again, remember, this is my daughter's sketchbook, so these random beautiful art pieces are not mine. We are still looking to multiply to negative 15. We only have 4 options. The catch is that when we're adding to this negative 7, one of our numbers is going to get multiplied by 2. You can definitely guess and check. You want a negative 7, so I'm going to attempt this negative 5 here and this 3. 2 times negative 5 is negative 10. Negative 10 plus 3 is negative 7, so that's what I want. What gets tricky about this is that this negative 5, in order to be multiplied by 2, is actually going to go in a different parenthesis, because if it's in the same parenthesis, it is not going to be multiplied. So I'm going to have this 2x plus 3 and x minus 5. Again, because 2x times negative 5 gives me negative 10x. 3 times x gives me 3. Negative 10 plus 3 is negative 7, which is what I want. If this 5 were over here, it would not get multiplied by the 2, so we would not add to what we need. So we want 2x plus 3, x minus 5. That would be this one. And this is what would happen if we had switched it around. This would give us just a positive x and not the negative 7x that we want, so it is B.